Welcome back, students. Now we'll move on to the inorganic portion in the form of some p block elements. So here p block elements usually consist from group number 13th to which one? 18th. But as far the first p is concerned, we are having only the what? The two groups, that is called as the boron family and then the carbon family, which are indirectly the group number 13 and then group number 14th. Okay. So here in the second PU we will move on to the which one? In the second PUC we will have the another four groups in the form of nitrogen family, carbon family, nitrogen family followed by the oxygen family, halogens and then the noble gases. But here we are concentrating only on the which one? The 13th and then the 14th group, that is called as boron family and then the carbon family. Okay. So let's move on to directly the solving of some of the multiple choice questions related to this some p block elements. Let's start with first. On the addition of the mineral acid to an aqueous solution of borax, the compound that has been formed is. Usually mineral acids means the inorganic acid. The best examples for mineral acids in the form of the sulfuric acid or nitric acid or maybe the hydrochloric acid. So here borax is actually called as a sodium tetraborate with a decahydrate. Usually by removing that particular Na2B4O7, this is called as anhydrous sodium tetraborate. When it made to react with which one? The sulfuric acid called as a mineral acid in support of which one? Water. Upon addition of this, we are getting first sodium borate is converted in the form of sodium sulfate and that is removed in the form of H3BO3. This is called as orthoboric acid. Orthoboric acid. It is neither a boron dihydrate or it may be the metaboric acid or the pyroboric acid. Metaboric acid is HBO2 and then pyroboric acid is H2B4O7, means it is the acid with respect to the borax salt. That is, instead of Na2, if I put H2, then it becomes what? Pyroboric acid. If it is a borate, means it is called as the metaboric acid. So here, with respect to the first one, it is going to be the what? Orthoboric acid. Okay. Let's move on to the second one. The main constituents with respect to which one? The coal gases. What are the main constituents with respect to the coal gas here? So coal gas means usually it consists of the methane along with the carbon monoxide and then the hydrogen. Usually the coal gas, it is coal on destructive distillation gives rise to various components, and this component, one of the component is found to be the what? The coal gas, and that coal gas contains the which one? The methane, carbon monoxide along with which one? Hydrogen, in which the methane is found to be around 23%. So here the highest percentage with respect to this is 56% of hydrogen and then 23% with respect to which one? The methane, and then nearly 10 to 11% with respect to which one? Carbon monoxide. That is usually 10 to 11% or 11% with respect to, and this particular combination is called as what gas? The coal gas. Okay. So let us have the third one. Which element of the group 14 elements? Group 14 elements forms only one hydrate. So carbon, we know that it is having a name itself is a hydrocarbon, means all are the hydrates of which one? Carbon. Means we can have the innumerable number of which one? Carbon. Silicon has, carbon has large number of hydrates. Large number of which one? Hydrates. Whereas silicon is having silicon tetrafluoride, so tetrahydrate and then disilicon hydrate, or simply the trihydrate. Sn is in the form of SnH2 and then SnH4. But lead is having only one hydrate in the form of PbH4, means that is a one and only hydrate with respect to which one? The plumbous element, that is called as lead. Lead existed only the one type of hydrate of the formula PbH4, whereas tin and silicon will have at least two of their hydrates, whereas the carbon has a very large number of which one? Hydrates with respect to the 14th group elements. Okay. Let's have the fourth. So here the fourth one is which of the following process doesn't involve a catalyst? Means it's one process where we can't expect the catalyst nature, or there is no need of a catalyst here. As if we are very familiar with respect to Haber process and then the contact process. Haber's process refers to what? Nitrogen combines with hydrogen in presence of which one? To form ammonia. So it is catalyzed in presence of iron powder as a catalyst, molybdenum acting as a supporter. In the contact process with the K reaction or the main reaction with respect to this, the oxidation of sulfur dioxide to sulfur trioxide, either using vanadium pentoxide or platinum exhibiting as a which one? Catalyst. Whereas in the Oswald process for the manufacture of which one? Nitric acid, where the nitrogen combines with oxygen in presence of the platinum rhodium as a catalyst. That is the manufacture of nitric acid by which one? Oswald process, where nitrogen combines with oxygen to in presence of platinum rhodium acting as a catalyst to form which one? The nitric oxide. Nitric oxide and further oxide is used nitrogen dioxide, and nitrogen dioxide is absorbed by water to form nitric acid. That is, this also involves a catalyst called as platinum rhodium catalyst. Platinum rhodium. But here the thermite process, it's a metallurgical concept, where aluminium reacts with Fe2O3 to form Al2O3 plus M. Make that as M here. For example, iron, let us call that as. This mixture is called as thermite. Means they are in the ratio of what is to what? 1:3 mixture of aluminium and then the powdered aluminium oxide is called as what? The thermite mixture. So here there is no need of a catalyst, but it requires a high temperature. That is why this process is particularly called as what metallurgy? Pyrometallurgy. Means we are extracting the metal by heating to a very high temperature. That is why it is called as what? The pyrometallurgy. So that is why during this a large amount of heat is liberated. Means it is a highly what reaction? Exothermic reaction. That is why this particular heat is used for the thermite welding process. That is why the name of that one is called as the thermite process. Thermite means it is an 1:3 mixture of which and which? The powdered aluminium with the metal oxide that we have chosen. So here aluminium is not acting as a catalyst, but it is using as it is acting as a what agent? Reducing agent. What it reduces? Aluminium reduces metal oxide to respective metal. Means it is in the process called as what metallurgy? Pyrometallurgy. Therefore it is found to be the what? A. Fourth A. Let's move on to the fifth one now. So here graphite. What's that? Graphite is made by heating how? Coke with silica for many hours in a blast furnace, a blast of steam and a pressure in presence of air, or it may be the high electric arc furnace. Usually these two refers to the metallurgical process, means we are extracting the metals by heating to a very high temperature in the form of either the blast furnace or it may be the blast of steam under furnace or pressure. But these two we can expect, but there is no need of air here. So here coke means carbon combines with which one? Silica. So here graphite has to be obtained. First there is a formation of silicon carbide plus the removal of carbon monoxide or it may be the carbon dioxide. Here that silica now combines with this carbon to form carbon monoxide or carbon dioxide. Here it forms graphite in the form of this, that is silicon plus silicon carbide. On heating it converts into silicon plus carbon, and this is particularly called graphite. But here electric arc is necessary, means that has to be heated by presence of which one? High electric arc. So this is called silicon carbide, and this silicon carbide is called as carborundum, an intermediate that has been obtained during the preparation of graphite from which one? Coke is the carborundum. That is carborundum is called as a silicon carbide, means it is a carbide of which element? That is a silicon. Therefore the fifth is found to be the what? D. Means graphite is made by heating coke with which one? Silica for many hours only by heating by the higher electric arc furnace. Okay. So let's move on to the sixth one. When orthoboric acid is heated, what happens? Orthoboric acid, when it is heated, what happens here? Boron is formed, metaboric acid or boric anhydride, or it may be the boron oxide or borax here. H3BO3, what is this? This is called as orthoboric acid. When it is heated means it removes the molecule of which one? Water. So here, after the removal of water, it forms B2O3 plus H2O. So to balance that, we will have 2 here. Here it is 2. Means this is called as anhydride of which one? The boric acid. This is called as hydride of B2O3. Whereas this is called as anhydride of boric acid, H3BO3. Therefore, the name with respect to the heating product or the product that has been obtained by heating orthoboric acid is found to be the boric what hydride? Anhydride. Anhydride means the removal of water, or the compound that has been formed by the losing of water is called as anhydrides. As it is obtained from the boric acid, the compound name is found to be the what? Boric anhydride. Okay. 6C. Let's move on to the 7th one. A kettle which becomes further in use has inside a deposit composed of mainly the calcium carbonate, magnesium bicarbonate, magnesium sulfate and then the sodium sulfate. Usually kettle, we know that it is used for pouring a hot drinks. Usually that coffee, or it may be the tea, or it may be sometimes the hot water also. Suppose if hot liquid, preferably the water that has been present, either it may be in the form of a coffee or the tea, or maybe it's a little bit only the hot water. Suppose if this is found to be the impure, it is found to be the what? Impure. It contains the bicarbonate of either the calcium or it may be the magnesium. What the hard water consists of? The bicarbonate of which? Either the calcium ion or it may be the, as it is boiling means it is at a high temperature, means this bicarbonate is converted to carbonate of either the calcium or it may be the magnesium, along with the removal of which one? Water. Means we are getting the white deposit of which one? The white deposit of which and which are formed? Either the calcium or it may be the magnesium. That is why the kettle becomes what? Filled up. Means it forms a small bubble inside that one. It is having a hard pasty mass, and that pasty mass is due to the formation of which one? Either a carbonate of a calcium or it may be the which one? Magnesium. Therefore, it is found to be the, there is only the what carbonate given, it is the. So another thing is, you are very familiar, bicarbonates are always unstable compared to that of which one? Carbonates. Means bicarbonates on heating can be converted to what? Carbonates. But carbonate doesn't get decomposed readily. Only in few cases only we can expect the decomposition. Therefore, we can have the furred nature of the kettle is due to the formation of a white deposit of calcium carbonate. Okay, that is 7th A. Next, 8th. In aluminates, what is the coordination number of? Usually, even though it is not an example for a transition element, it exhibits the coordination compounds formation. Means aluminium is having a coordination number of what? 6. For example, AlH2O with what? 6 times of 3 plus, whatever may be the cation that has been, whatever may be the anion that has been present. Or suppose if it is having any of the other ligands, for example Cl2, we can expect it is going to be the plus 3. Means in every case, what is the formation here? The coordination number with respect to aluminium metal is going to be how much? It is only the 6. You have to remember very clear, that is aluminium coordination number is always 6, which is having an oxidation state of what? Again plus 3 here. So here it is as if it is -1 plus 3, here it is 0, therefore it is the total charge outside this one is going to be the what? Plus 1. Okay. So 8th is B. Next we will move on to the 9th. The correct order of decreasing nature of lead dihalides. Decreasing order of which one? Ionic character. Nature of lead dihalides is. We know that 14th group is having a configuration of NS2NP2. So that if it loses this, we can expect this. If it loses both of this, it becomes first. So here, down a group, the +2 oxidation state is more, whereas down a group +4 oxidation state is less. And these two is due to the one effect that is called as what effect? Inert pair effect. Means the last two valence electrons of the ns orbital is not involved in the which one? The chemical bonding, such that the two electrons penetrate into these ns2 electrons penetrate into which one? n-1 d orbital, such that they becomes very close to the which one? Nucleus. As it very close to the nucleus means it doesn't loses the next two electrons. That is why we can expect the +2 oxidation state goes on increasing down a group compared to that of which one? So here we are having the one what effect it is? It is the inert pair effect, followed by here we are asking the ionic nature. Ionic nature means more the difference in electronegativity, more is the what character, or indirectly lesser is the what character. Means it is indirectly we can say that it is the Paget's rule in the formation of a covalent bond. Means lesser the difference in electronegativity, more is the what nature? Covalent nature. Means more the difference in electronegativity means more is the what nature? Ionic nature. So here lead is common in every case, I think. Pb 2+. Among fluorine, chlorine, bromine and iodine, which is more electronegative, it is the fluorine. Means the difference in electronegativity between these two is found to be the what? Difference in electronegativity is maximum, whereas this is also +2, here it is also -2. The difference in electronegativity is what? Difference in electronegativity is less. More the difference in electronegativity means more is a what nature? Ionic nature. Therefore the order with respect to the ionic for dihalides is lead fluoride is more ionic compared to that of lead chloride, followed by lead bromide, and finally the what? The lead iodide. Okay, so that is 9th A. Next 10th. Sorry. Okay. Dimethyl silicon chloride upon hydrolysis, what happens? Will produce what? Me twice SiOH twice, Me twice SiO, OMe twice SiO, and then finally the Me2SiClOH. So here the hydrolysis of which one? Dimethyl silicyl chloride SiCl2 upon what lysis? Hydrolysis. As it contains two chlorine atoms means we can have the two replaceable, means there is a removal of two what? HCl. Therefore Me2SiOH twice. But these type of compounds are highly unstable, because anything which can be occupied by the two or more hydroxy group to the same are found to be what? Highly unstable. Therefore they readily loses a molecule of which one? Me2SiO, or this is mentioned as Me2Si double bond O. So here this is also unstable. Why? Because silicon being the larger size, what size? The larger size, it doesn't have the formation of the covalent bond or the double bond with respect to which one? The oxygen. That is why instead of that it undergo what? Polymerization, such that SiO is formed with how many times? N times, and here also it is Me twice with O followed by this. Means it undergo what? Polymerization. This is not a stable compound. Actually this is a product obtained by the dehydration of this dihydroxy compounds, but this is silicon being the larger size, that it doesn't have the formation of a p-pi bond, or it may be the double bond between them. That makes the instability such that it behaves as a monomer, and that monomer gets polymerized to form a polymer of the type, this one, that is of the type that is called as C. Okay, so this is the hydrolysis compounds with respect to which one? Me twice SiCl2. Okay, so that is 10C. 11th. The least stable hydride is, which is the least stable hydride in case of The methane, carbon, silane and then stilbene. Means they are the CH4, plumbane means PbH4. Next about the silicon. Silicon means SiH4. This is methane, this is silane, this is stilbene and this is the plumbane. So here plus 4, plus 4, plus 4, plus 4. As if we already mentioned. What is that? The plus 4 Pb 2 plus is far greater compared to that of Pb 4 plus. This is due to the inert pair effect. Means lead in the plus 4 is not stable. Therefore, we can have the least stable with respect to that one is going to be the plumbane. Why it is plumbane? Because the plus 4 oxidation state is not stable with respect to lead because of the what effect? Inert pair effect. Or indirectly, the basic character or the hydride nature, basic nature of hydrides decreases down a group. Down a group. Means the basic character with respect to which one? The hydrides goes on decreasing. Whereas the basic nature of the hydroxide gets increasing. But the hydrides goes on decreasing. That is why the least basic or the least stable hydride is going to be the what? The plumbane. Okay. 11b. 12. Let's move on to the 12, sorry. The bonds present in which one? Borazole. Borazole is also called as what? Inorganic benzene. Inorganic benzene is. So we know that C6H6. So here B3N3H6. This is called as borazine, which is also called as the inorganic benzene. So here alternate we are having the NBBN. As usual, first the covalent bond has been fixed. H. But as if we know that each nitrogen has a what? Lone pair of electrons. Boron is trivalent, okay, but nitrogen being a pentavalent due to the presence of what pair of electrons? Lone pair of electrons. What it will do? It is electron deficient and nitrogen is electron rich. Therefore, it forms a pi bond. Pi bonds are indirectly called as the double bonds here. Means, how many sigma first? The ring atoms are totally 6 here. Therefore, the 6 sigma in the ring and then the 6 Bn sigma bonds first, 6 Bh sigma bonds and then 3 N double bond B pi bonds. Indirectly it is nothing but the what? The pi bonds. Means totally how many sigma and how many pi are there here? It relates to the 12 sigma and then the 3 pi with respect to which one? The bonds present with respect to the borazole, which is simply called as what? Benzene, inorganic benzene. Therefore it is 12A. Okay. Let's move on to the 13th. What's the 13th here? Aluminium metal is corroded in coastal places near to the sea because protective oxide film. Usually, aluminium is the best example for a self-protecting metal. It's the best example for a what? Self-protecting metal, because when aluminium gets exposed to the air, it forms a thin and then the insoluble layer of which oxide? Which prevents the further reaction with the air. Further reaction with air. That is why the aluminium is the best example for first self-protecting metal. But when it is in the coastal area, means usually it contains a what? Seawater. Seawater means it contains a large number of what? Salts. That salts can destroy the protective oxide layer that has been present. Therefore, it easily gets corroded. Means Aluminum doesn't easily get corroded when it is exposed to air, but it gets corroded only in support of which one? The seawater, because the seawater contains the dissolved salts of calcium and magnesium, and that reacts with the aluminum oxide to form either the aluminum chloride, aluminum preferably the chloride. Means it is readily attacked by the which one? The salt that has been present in the what water? Seawater. Therefore it is 13C. Okay. 14th, when a tin is heated with a nitric acid, what it forms? It is converted to stannous nitrate, it becomes passive, it is converted to stannic nitrate, it is converted to metastannic acid. So here, concentrated nitric acid, we know that it is the best example for a what? Oxidizing agent, because it itself gets reduced to nitrogen dioxide by the loss of nascent oxygen. And this nascent oxygen, when it is attacked by which the metal here? Sn, it forms its oxide of the form, what is that? SnO2. So here, this SnO2 is having a more affinity towards the water that has been present, therefore it forms H2SnO3, and this is called as metastannic acid. Metastannic acid. In rest of the cases, it may form stannous nitrate or it may be the stannic nitrate, but in case of the concentrated HNO3, because concentrated nitric acid is the best example for a stronger oxidizing agent, where it first oxidizes tin to which one? Tin oxide, and that readily absorbed by the water to form an acid, and that acid is called as metastannic acid, along with the liberation of what gas? Nitrogen dioxide. Therefore it is converted to what? The metastannic acid. Therefore it is 14th D. Okay. Next is annealing of glass is done to make what? Brittle, make it opaque, check it from becoming the brittle, make it transparent. Usually, when the glass piece, for example, when it is heated and then cooling suddenly, it becomes hard and then brittle suddenly. The process is called as hardening of glass. Hardening of glass. Suppose if the same red hot heat is cooled slowly in a homogeneous mixture under cool conditions, it becomes, there is no hardness, or it may be the brittleness, and this process is called as annealing of glass. Means the very slow and the homogeneous cooling of the which one? The molten glass to form, it doesn't convert into a brittleness, is called as what? Annealing of a glass. Therefore the annealing of a glass is conducted to check it what? The from becoming a whatness, the brittleness along with the which one? Hardness. Okay, so that is 15th B. Next is 16th. The reducing power of which one? The dihalides, decreases in the order. What's that? The reducing power of divalent species decreases in the order. Divalent species. Germanium, Sn, and then Pb2 plus. What these are? They are the divalent species of the germanium, tin, and then the lead. As we know that Pb2 plus is more stable compared to that of this. Means lead is converted to lead 2 plus by the loss of 2 electrons. If it loses 2 electrons, means it is a strong what agent? Oxidizing agent. When it is, if it is a strong what agent? Strong what agent? Reducing agent. When it is, if germanium independently Sn is converted to this is converted to plus 2, this is converted to plus 2, this is converted to plus 2. Therefore, it readily gets oxidized first. Readily gets oxidized due to the what effect again? Inert pair effect. Therefore, it is a strong reducing agent. What agent here? Reducing agent. But here, this Pb2 plus has to be converted to Pb4 plus. It is less. Why? Because of same what effect? Inert pair effect. Plus 2 is found to be more stable compared to that of which one? Plus 4. Therefore, it is considered to be the weak reducing agent. When I am comparing the what? Divalent atomic. If it is an monoatomic, if it is an atomic state, lead is a what agent? Strongest reducing agent. But with respect to divalent doesn't get easily oxidized because of the what? Inert pair effect. Therefore, lead 2 plus is an example for a weak what agent? Reducing agent. Lead is a weak reducing agent, means the order is what? Therefore, with respect to divalent, the order is germanium is greater than, tin is greater than which one? Lead. Therefore, the option with respect to that is what to be the what? Suppose if they doesn't give the divalent species, the divalent species is not given, what you have to mention? The reducing properties in the order what? Lead is greater than, Sn is greater than germanium. As if the divalent species is given, germanium is going to be the stronger compared to that of lead, tin followed by the last is lead. Okay. Therefore, it is the 16th of what? A. Okay. Next, we will move on to the 17th. There are how much? 2 hydrogen bridge atoms with respect to which one? The boron molecule, diboron molecule. Because there are only 12 electrons, there are 14 electrons less than required for the bonding, 14 electrons, 2 electrons less for the required, and then the 2 electrons more than required for this one. So, as if we know that BH3 doesn't exist, BH3 is highly unstable. H, and then H. As it is having 1 electron species for it. Here the same thing, H with H. It's an odd electron species, but here this becomes a hydrogen bonded and this becomes a what? This is a 3-centered 2 electron species. What's that? 3-centered 2 electron species. Means there is a it is a deficient of how many electrons? 2 electrons, which involves the formation of a what bonding? The hydrogen bonding. So this is also called as what bonds actually? The banana bonds we are also calling that as. It is called as what? Hydrogen bridge bonds are also called as here the banana bonds. Therefore, there is a less of how many electrons? 2 electrons with respect to that. Therefore, BH3 doesn't exist. BH3 is unstable. It dimerizes to form B2H6. Okay. So that is about the 17th in the form of what? C. Okay. Next, we will move on to the 18th. What's that? 18th. Boron and another one is aluminium exhibits for that many properties which are quite similar, but the 2 elements differ. Boron and aluminium, they can have the similarity in major of their properties, but they differ in what? Exhibiting the amphoteric nature in their oxides. Both boron oxide and aluminium oxides are amphoteric. They are the best examples because they can dissolve not only in the acid but also the what? Base. Yes, that is right. Forming the polymeric hydrates. As if we have mentioned, there is a formation of a polymeric hydrates. Okay. Then forming the covalent halides because due to the diagonal relationship between them, they shows a what character? The covalent character rather than the ionic character. Then exhibiting the maximum covalency in both the cases. Usually, the maximum covalency of boron is 4, whereas aluminium is 6. Because in case of this one, the coordination number is 4. Here in the case of coordination number is what? 6. Means we can have the difference in the covalency. That is the maximum covalency with respect to boron is going to be the 3 plus additive 1 because of the incomplete p orbital. Whereas here we are expecting the maximum covalency with respect to aluminium is going to be the 6, whereas the rest of the properties like what is that? Amphoteric nature, forming of the polymeric hydrates, and then the covalent halides are going to be the similar, but not the which one? The 4th one. That is, 4th is not similarity with respect to boron, and then which one? The aluminium. Okay. Let's move on to the 19th right now. Thallium shows what effect? Different oxidation states. Why? Thallium shows a different oxidation states. Why? It's a transition element. No, thallium is an example for a 13th group elements. Therefore, we can't expect this. Then maybe a chance of which one? Inert pair effect, of its amphoteric nature, of its higher reactivity. So of course higher reactivity, but that higher reactivity doesn't make the different oxidation states. If it is higher reactivity for the metal, means it is nothing but alkali, or it may be the alkaline earth metal. And also aluminum also an example for a what? Highly reactivity. Therefore this is not also possible. Then thallium, it is strictly the what? Metallic oxide. Metallic oxides means it is basic oxide. Therefore it is not amphoteric. Therefore it is due to the one and only. What it means? The last element, usually what we are preferring, the inert pair effect starts from n greater than or equal to which one? 4. Means when the inner pair effect starts here, n either equal to 4 or it may be the greater than 4. And also inert pair effect increases with increase in 1, where n is greater than or equal to which one? 4. Means the last element always gets the highest of the what effect? Inert pair effect. Okay. So that is about the answer with respect to the different oxidation state for thallium is going to be the what? B of what effect? Inert pair effect. Okay. Let's move on to the 20th here. Boron nitride. What is that? Boron nitride reacted with what? Caustic alkali. Caustic alkali means either sodium hydroxide or it may be the potassium hydroxide. What it forms? It is one of the preparation actually. Boron nitride is Bn because nitride is -3. Therefore, this is boron is also trivalent. Both are trivalent. When they react with either a solution of aqueous NaOH or it may be the KOH. So what it forms? So here it forms an acid of the type H3BO3 plus the liberation of which one? Sorry, it is the sodium borate, Na3BO3 first. Na3BO3, a salt of which one? This, along with the formation of which one? Ammonia. Means the nitride of boron reacted with the caustic solution of sodium hydroxide to form sodium borate along with the liberation of which gas? Ammonia. Means it is indirectly one of the preparation for which one? Ammonia also. Okay. So that is 20A. Next 21. What's that? When a mixture of sand and potassium nitrate is heated strongly, the product or products are is. What reacts with what here? Sand reacts with potassium nitrate. Sand is actually SiO2, silica. It is called sand. Made to react with a solution of which one? Potassium nitrate. Potassium nitrate. As it forms the silicates of the salts. Silicate means Si O3 2 minus. What type of silicate? It is a potassium silicate. Therefore it is K plus. Therefore the formula with respect to that one is K2SiO2. It is called as potassium silicate plus. As usual, potassium nitrate means there is a liberation of this and also the liberation. Because nitrate salts, NO3 minus, always decomposes to what and what? NO3 minus decomposes to form what and what? Nitrogen dioxide plus oxygen. Therefore, it forms potassium silicate along with nitrogen dioxide and then the oxygen. Therefore, NO2 is there, O2 is there, K2SiO3 is there. Therefore, the product with respect to that one is going to be the D. Okay. So that is 21D. Next, we will have the 22. What's the 22 here? Which one of the following is correct? Statement is going to be the correct. The hydroxide of aluminum is more acidic than that of boron. The hydroxide of boron is basic while that of aluminum is amphoteric. It is a correct statement. Okay. The hydroxide of boron is acidic while that of aluminum is amphoteric. The hydroxide of boron and aluminum are found to be the what in nature? The amphoteric in nature. So what is the answer with respect to this? The hydroxide of which and which? Boron and hydrogen. Boron means boron hydroxide. Aluminum means aluminum hydroxide. So just by seeing the formula, we can immediately say that both are hydroxide means they are found to be the basic. No. So here it is mentioned as H3BO3. It is called as orthoboric acid. What acid is this? Orthoboric acid. Means B is surrounded by OH here, OH here, OH here. But these are not replaceable here. So for that, it gains the OH minus right now, because right now in the last previous question I have mentioned the maximum covalency with respect to the boron is found to be the what? 4. Therefore, it forms B OH 4 times with what? Minus. Means it is not donating a proton, it is not a protonic acid, it is accepting which one? Hydroxide. Therefore, it is one of the exceptions with respect to the mineral acid in the form of orthoboric acid. Therefore, this acid is what? Acidic. Hydroxide of boron is what? Acidic. Whereas aluminum hydroxide, as if it gets converted as this alumina, because after losing the water, it can react not only with HCl but also with NaOH. Means it forms NaAlO2 plus the liberation of hydrogen gas here. Here also it forms AlCl3 plus the liberation of hydrogen gas here. Means aluminum hydroxide or alumina not only dissolves in the acid but also with the base. Therefore, it is an example for a wateric amphoteric. Means the hydroxide of boron is what? Acidic. By looking the formula, we can immediately say that it is basic. No, it is not like. Exception for boron acid. It is found to be the acidic in nature, while the aluminum hydroxide is found to be what in nature? The amphoteric. Therefore, the option with respect to the 22nd question is what? C. Okay. Next, we will have the 23. The composition of which one? Mica is. Mica is a silicate of both the potassium and then the aluminum. That's it. The silicate of both the which and which? Potassium and aluminum is considered to be the what? The mica. So here we are having the potassium along with the aluminum silicate. Therefore, it is in the form of this. The composition you have to remember, K2O 3 times of Al2O3 with the 6 times of SiO2 dot 2H2O is called as what? The composition with respect to mica. Okay. Let's move on to the 24th. Diborane reacts with which one? Water to form diborane. Diborane means B2H6 reacts with which one? Water to form. So here it forms diborane means borate means it is a composition with respect to orthoboric acid, but the liberation of which gas? Hydrogen gas. Okay. On that basis, it is the mixture of both which and which. It is the orthoboric acid along with the liberation is obtained when diborane reacts with which one? Water. That is the reaction of diborane with water. Means not only we are getting the orthoboric acid but also the liberation of which one? The hydrogen gas. 24C. Next, about the 25th. The thermal stability with respect to which one? The thermal stability of order of the group 14 halides is. What are the stability with respect to this? It's as if, I think in every case it is a +2 oxidation state. We know that for 14th group, the stability of +2 increases down a group, whereas +4 decreases down a group. So as it is in a +2 means the lead is always more stable first. Then the previous that one is Sn2 plus then the germanium followed by which one? The silicon. This is the stability. Why? Because same. What effect? Inert pair effect. Because +2 for lead is always stable because of the what effect? Higher inert pair effect. Therefore, which dihalides are more stable? Lead halides are more stable compared to that of tin halides formed by germanium halide and then the silicon. The option with respect to that one is found to be the 25C. Okay, 25C. Next, 26. 26. It's a direct question here. The minerals having a what? Silicates chains are collectively called. Means the minerals having a silicate in the chain form are called as pyroxenes. They are the commercial names with respect to the silicates which is having a what? The chain form. That is 26C. 27. Stable compounds of which one? The +1 oxidation states are formed by, what is that? Stable compounds of this one are stabilized by, again the +1. For +13th group, stability of +1 increases down a group, whereas +3 decreases down a group. For 14th, plus 2 and plus 4. Plus 2 increases down a group, whereas plus 4 decreases down a group. Whereas in case of the what group? 13th group, plus 1 is stable for the, it goes on, increase down a group, and plus 3 goes on decreasing. Which is the last element? It is a thallium. Means thallium is going to be the what? More stable. Thallium means it is the TL. Therefore it is D. Okay. So 27 D. Next we will move on to the 28th. A particular elements belong to the group 13th and second period of the periodic table. It is what? Here it is a 13th group, means it is a what family? Boron family. Boron, aluminium, gallium and so on. Last one is thallium. Okay. And then the second period means it is the boron. Means 13th group of second period elements is called as what? Boron. What boron is? It is not a gas, it is not a liquid, but it is a solid. And boron is an example for a what? The first elements, the topper elements are the non-metals, and the lower elements are going to be the what? Metals, and the intermediates are found to be the what? Metalloids. Therefore, we can say that boron is found to be the solid nature with the what nature? Non-metallic nature. Okay. So 28 C. Next. Carbon monoxide will not reduce. Lithargy is actually PbO. Lithargy is, lead oxide is also called as what? Litharge. Carbon monoxide will not reduce litharge, cupric oxide, zinc oxide, and then the ferric oxide. We know that ferric oxide is readily reduced by carbon monoxide as if we were extracting the metal of iron, cast iron from hematite. Means carbon monoxide is a better reducing agent at what temperatures? Lower temperatures. As if we know that zinc oxide combines with this at 1122 or nearly approximately with this temperature, 1200 Kelvin. We are getting zinc plus carbon monoxide. Means zinc is a better reducing agent than carbon is a reducing agent, better reducing agent than zinc above around what is that? 710 degrees Celsius. Whereas carbon monoxide is a better reducing agent above or sorry, it is less than 710. Here it is going to be the greater than 710. Means we can't select carbon monoxide as a better reducing agent for which one? The zinc oxide. But those are, or simply we can say that zinc is not, it is a stronger what agent? Stronger reducing agent than carbon monoxide when it is heated above how much? 710 degrees Celsius, that we already discussed in the concept of which diagram? Elegant diagram. If it is below 710, which is the better reducing agent? Carbon monoxide. If it is above 710, means it is found to be the what? The carbon is a better reducing agent. Therefore, carbon monoxide cannot be a reducing agent with respect to which oxide? Zinc oxide. Okay. So 29 C. Let's move on to the 30th. Solid carbon dioxide is used for what purpose? As a poison, a fire extinguisher, then a refrigerant, or an artificial respirant. What the solid carbon dioxide is called as? Dry ice. Solid carbon dioxide is called as what? It is also called as what ice? Dry ice. Means CO2 solid on just exposing to air, what happens? It directly converted to this. Means it gets a sublime. How it gets sublime? By absorbing the heat. Absorbing the what? Heat. From the which one? Surroundings. What happens when it absorbs the heat from the surroundings? Means, so here that particular carbon dioxide, it gives the heat to this one, that is in the form of, that is absorption of heat due to the what? It makes the cooling of that one, that is why it is used in the form of which one? The refrigerant. Means it directly converts from what state to what state? Solid state to the which one? Gaseous state, such that it is obtained by the absorption. What happens when it absorbs the heat? Means the surroundings heat becomes less. If the heat is less, means it starts to cool, and that coolness makes the use with respect to what? The refrigerant. That is why solid carbon dioxide is the best example with respect to the refrigerant. Okay. In silicon, which one? Hexafluorido anion, and then hexachlorido 2 minus ion, which one is found to be the known and then the Y. So here, silicon plus 4 first. It is occupied by 6 times of F minus R, 6 times of Cl minus in both the cases. If I combine these two, it becomes SiF6 with what? 2 minus. If I combine with this, it becomes SiCl6 with what? 2 minus. So here, which is known and which is not known? So here these two combine to form SiF6 with 2 minus. Here these two combine to form SiCl6 with 2 minus. This is not known and this is known. Why? Because first, silicon being a smaller sized element, it is shared by 6 because this fluorine is found to be the what? Smaller size. And this is found to be the what? Larger sized. Means we can't accommodate the 6 chlorine atoms around the silicon 4 plus ion. That is why there is an existence of only the SiF6 2 minus but not the SiCl6 with what minus? 2 minus. Therefore, we can have these two SiF6, these two are correct and the smaller size. And the reason for this one is found to be the A. Means which is known? SiF6 2 minus is known. Why it is known? Because it is having the, which is having that? The fluoride is having a smaller size. Therefore, it is 31A. Which one of the following, 32, which one of the following doesn't exist in the free form? Boron trifluorides, boron trihalides are best known. BX3 are known because of stable what hybridization? sp2 hybridization. But boron hydrates is exhibited by the general formula BnHn plus 4R, BnHn plus 6. This is the general formula for the hydrates of which one? Boron. That is, if I put N is equal to 1 for example, it becomes BH4, but BH4 is highly unstable. But N starts from here at least to 2 here right now. If I put N is equal to 2 means here that is B2H6, B2H8 is means as if I mentioned that BH3 doesn't exist but B2H6 can exist. Why? Because of the 2 electron shortage between the 2 BH3 molecules such that it forms a 3-centered 2 electron species, which is due to the formation of how many hydrogen bondings? 2 hydrogen bondings, and that is called as the banana bonds. Means there is no real existence with respect to which one? The BH3, but all the halides of boron, preferably the trihalides but not the pentahalides. Okay, therefore it is 31 is B. Okay, next 32, okay. Next is 33. Aluminium chloride exists as dimer. Why? Because aluminum has a greater ionization potential, aluminum has a larger radius, high charge nucleus, and then the incomplete which orbital? P orbital. Means we can expect AlCl3 exists in the form of AlCl3 exists in the form of Al2Cl6. This is most stable and this is less stable. Why? Because aluminium Cl 1, 2, 3, 4, 5, 6. So here there is a shortage of this, and this aluminium, let's have this first. This is electron deficient. This is electron deficient. This is also electron deficient. Means it is a Lewis acid. Due to that, it gives the 2 electrons through the which bond? Coordinate bond. And here it gives the 2 electrons, not giving, it is the sharing unequally to form a what bond? Coordinate bond, and that existed in the form of which one? Dimer. Means AlCl3 doesn't easily exist. Even though it exists, it is found to be highly unstable. Instead of that, what it will do? It start to get dimerized. How the dimerization takes place? It is not due to the hydrogen bonding, what we have discussed in case of diborane, but it is due to the formation of a coordinate bond between the chlorine of the first aluminium chloride with the aluminium of the second aluminium chloride molecule, or the hydrogen bond, the coordinate bond between the chlorine of the second aluminium chloride with the aluminium of the first aluminium chloride molecule. Therefore, it exists in the form of which one? The dimer. Okay, means aluminium chloride always, this one, it is due to the electron deficient center. Electron deficient center means it is having an incomplete with respect to which orbitals? P orbitals. Okay, so this is about some of the questions that we have discussed in the first session right now. So okay, we will continue the same in the next session for the some p block elements, that is both the 13 and then 14. Okay, so thank you very much.